Hello, viewers. Welcome to my show, Rocket Monday. In today's episode, we're going to talk an interesting topic about Astro B NASA robot that is right now in ISS. So let's dive right into it. So first, we have to understand what the heck we are talking about. Well, we are talking about a free-flying robotic system. Now, again, free-flying simply means it does not need assistance. Nobody is gonna be there, controlling it with the remote control. They're just gonna tell it like go point A to point B, and like Unity module to let's say Japanese module. They're not gonna be like okay, control send it to remote control. So it's completely autonomous. Now, it's a system. It's not meant for one robot system to do everything. They're gonna be three. Now, each of them have their own unique names, and the aim, what the heck they are supposed to do is reduce the workload in ISS, and they're supposed to work in teams because they are talking about low G environment, basically zero G. They can do quite amazing things if they are working in teams, basically quote unquote swarm robotics. Question becomes why the heck we want to do it. Well, astronauts have a lot of repetitive work. Basically, you may think okay, they are astronauts, they are cool, and they are scientists and engineers and whatever have you, but when you actually see their day-to-day dossier, is basically what you have to do when you get up to you go to sleep. It's a lot of repetitive work. Basically, you take 10,000 measurement, take 50,000 inventories, things of that nature. It's not glamorous nor it's useful. It's a and when I say useful, I'm like it has to be done. It's just that it's really not something that should take human intervention. So taking inventory, data logging, they want to put all those work into basically robot's hand rather than human, because there are experiments on ISS that are being conducted that require humans constant intervention. But again, because they have to do so many other things, so many repetitive things, those experiments do not get the attention they deserve. And not to mention many other experiments are rejected because they have so much workload. So that is why they wanted like okay, instead of your like half a day, just like a half a working day just dedicated to repetitive work, let's put let's reduce that to 25% or 10%. That would be a huge advancement to everything. Basically, if these people, again, they will feel better because repetitive work is not good for anyone, so they will feel better. And on top of that, more science can be done because they are not wasting time taking 10,000 readings and all that. So it is not something that luxury. It's something that will tangibly help our situation here. And not to mention, this is not the first time that we are doing something like this, because the moment we went into space, we realized it we need extra sets of eye, because from ground-based telescope you simply can't do anything. So the space shuttle era had their own football. Basically, it had cameras, multiple camera, and it had nitrogen thrusters that will help it to fly with its own light and all that. So it was controlled by ground control or the astronauts in the basically space shuttle itself, and it allowed them to have extra pairs of eyes. Basically, they can see, let's say there are two astronauts are handling the eye, basically Hubble telescope, and they had to see what's happening to the door and all the other mechanism. It can go around and see it. Basically, it was completely untethered. It was meant to work in space. This was Gen 1 basically. Then there is Gen 2, which is basically spheres. Now this was they tried to do everything inside the ISS, and they learned a lot from this. Basically, how the heck you're gonna handle fuel systems and all that, because again, think of them as a training ground. Basically, they learned the things how the heck you're gonna, let's say, recover spent boosters and all that in space from many experiments. So all of these missions, they taught us a lot of things. All of that knowledge is now being put into basically this system. Now, so how does this actually work in tangible definitions? Basically, if you have to understand this, think of this is just a drone. Now, when you are talking about drone on Earth, again, you can see it is very dangerous. You have spinning blades, so flat out you cannot have spinning blades in ISS. Not only it's dangerous for human, it could also damage the ISS, because ISS has a lot of exposed electronics, a lot of wirings, pipes and all that. So for that reason, you simply cannot have that. So, and there is one advantage of ISS, it's in zero G. So when you are talking about drones on Earth, most of the energy of drone, let's say you have 100 watt hour battery, most of that energy will go into one direction, and that is downwards, just to make sure they can cancel out the gravity. You do not have that restriction when you are in zero G or free falling. So they utilizing that freedom. They are this whole system is designed a bit differently. So they have one central impeller on the both side basically. So what this impeller will do is basically suck air in, pressurize it. Basically, take the air what is on normal 8 psi to 15 psi, pressurizes to whatever degree they want depending on the requirement, and then they control the release of it. Basically, you have the pressurized air. Now they're gonna be like they're gonna do it because there are nozzles all around the body. You can see these nozzles. It's like everywhere, all 360 degree, because it has to move in basically three axes: X, Y, Z. It has to move in all three, and it also must have the ability to twist and turn. So everywhere it's basically has nozzles. So impellers are pressurizing the air. That pressurized air being released, in small controlled amount using the nozzles, computerized nozzle. That's how it's flying in, quote unquote, flying in ISS. Basically, it's not flying; it's controlled floating would be a more appropriate term. Now, again, cameras are very important in ISS, because if you can have extra sets of eye instead of astronauts, relaying information back to the ground control. Is like, okay, this is what we are seeing here. They can directly have video feed from this puppy directly go into ground control. Right now, if they want to do something like that, they have to have astronaut go there, mount a camera, stay next to the cameras. Again, cameras are not built like, they don't have security cams there. It's not built to control it, and if they have to change the angle, they have to call the astronaut and do it again. So you can understand, basically the astronaut is occupied all the time. So this is supposed to alleviate some of those needs. Basically, if they need it without contacting the astronaut, they will be like, okay, there will be this bee coming around. It's like, let it go. It will go in that area and it will do the absorb, all the data logging that it needs to do. Now it is self-guiding, so it has navigation cam everywhere, basically all 360 degree of it, hazard cam to avoid basically hitting into other things. And the design is built in such a way that if it hits it, even at maximum velocity it can do, it will not cause any serious damage or injury to anybody. Basically, it's 100% quote unquote human safe. It has a laser pointer, power switch, and a touchscreen. Now, touchscreen is an interface, just like if you have to tell astronauts some critical data, you can just show it in front of them, and it will have cool animations just to make people feel a bit more comfortable around it. Now, on top of it, basically, you have most systems are occupied, but on top, like there is a bay, empty bay. Now, that bay is what we call payload bay. Now that payload bay will have this robotic arm. Now this arm is not there just to look cool or fancy and all that. It has a primary advantage, because ISS is in 0G environment. Everywhere there is handrail, so astronauts can move around. This will utilize those handrail as tripod mounting points. Basically, if for some reason they have to do a sweeping pan action and all that, they can just use the grip itself into a pan and turn off the impellers, because impellers consume a lot of power, and utilizing the small servo motors on the joints, they can move around. So it is very important. It will allow them to conserve energy and do long-term missions. So let's say for some reason they have to basically reboosting. Let's say Mir station is reboosting the ISS, then it will be physically moving, and if anything that is floating inside will be pushed back. So you will have this clamp down rather than it firing its thrusters at full power. So it is quite useful. On top of that, this can be changed with other things. Other payloads can be put into it. Like two primary payloads that I am aware of is basically radiation dosimeter, so they can get a thorough analysis rather than having few sensors. They can have full 360 degree every single square meter. It can keep going there and doing a full analysis. Basically, they can give, when it's sun side, this area gets more exposed. When it's a lunar side, this gets more exposed. Lunar side is where the moon is, because moon is also blocking a lot of gamma rays. So you can get the idea. There is a lot of advantage to be had. Something that can move anywhere in ISS, basically anywhere inside volume. Air quality sensor, that is quite critical, basically. So those are just two. There could be many more that I'm not even aware of, or maybe once it's actually out there, somebody will figure out other use cases, because you have to understand these are controlled by ground. They can be controlled from ISS itself, but they will also have a competition for students, 15-year-old students, school challenges known as 0G competition. In that, people will upload some codes into this to test it out. So it has a lot of advantages. Just a flying drone. So are there any use of this, spending this kind of money into it? Well, yes, because right now you may think, okay, all it can do is act as a camera and act as a flying sensor. Again, that's more than good enough for justifying its cost. On top of that, what it can unlock, that is much more interesting, because this is a test bed. By definition, it's a test bed. Basically, we have something, let's figure out what we can do with it. So they already have two right now, and they will have 10 more. So okay, do this on that. And let's say as the gripper become more practical, more capable, right now it has the ability to move objects in ISS. Basically, let's say they have to move one experimented from from docked spacecraft to Unity module or things of that nature. It can do that. Right now it can do that. What if we can have instead of 3, we can have 6 or 7 doing big chunks works. So all those, there are a lot of potential into this, and more experiment will lead us to figure out, okay, this it can actually do, this it cannot do, it sounds good on paper, it does not work, or this works, or astronauts may themselves figure out, hey, this could do this or that. So it is very important to understand, this is a test bed. This is just the opening. and this will help us with upkeeps. Now think of this way: ISS is in low earth orbit and it is always manned. There is always somebody in ISS 24 into 7 into 365 until its day of decommission. There always will be someone. Like, again, in case of emergency they may have to evacuate it, but so far it has not happened. So you have to understand this. It is like very well maintained. Now when you are talking about LobG, there is a very serious probability in LobG that LobG will not have that status where 100% of the time somebody is there occupying it. And not to mention, LobG is not also meant for that kind of people. Basically, LobG will not have same complement. Instead of 7 8, they may be reduced to 4 or 3. So in those sort of scenario, having this kind of robotics there, it could be a very good for maintenance. Let's say astronauts are going home, nobody would be there. These robots can help us as a extra layer of safety. Basically, they can fly around, double check everything, and next generation may have stronger arms that are more capable of doing things. So ground control could have a direct link, what's happening inside the station. So these are quite useful tools. And future exploration is like, let's say you have figured out some sort of hibernation for humans, and you froze everyone and basically shipped to Mars. During that 6 months, ground control can, utilizing this, can directly take care of the ship without requiring any astronaut to be awake the whole journey. So it's quite useful. It's not just a flying toy. It's a very useful tool. So this was my presentation on flying robot of NASA. I hope you liked it, learned from it. In that case, please click the like button. If you didn't like it, didn't enjoy it, I would urge you to press dislike, press it twice to show me your extra disappointment, and please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.